Okay, well, hello there. All right, all set. Let's code. So I'm still working on my seam carving solution to the seam carving puzzle on codinggame.com. Actually, my solution is, well, I thought I was done, but if you take a look here, when I run the test cases, well, it seemed to work until I hit this one right here. It doesn't like my output. I'm off by just a little bit for some reason. And the weird thing is that all subsequent test cases also fail. So what changes here that, you know, I'm not dealing with properly in my code? I have no idea. No idea. I'm going to have to debug this stuff. And I have a feeling it's what we're going to be doing this morning. A lot of debugging, maybe a little bit of refactoring, because the solution itself is pretty much done. So it's probably just a little bug somewhere, not handling some kind of case properly, calculation error, whatever. Now the creator of this puzzle, Mr. Niako, has been kind enough to supply me with some data regarding the test case that I am unable to pass, test case 6. And he's given me each path that is supposed to be removed, carved out of the picture, the index for each row, the pixel index for each row, and the pixel energy value corresponding to each row, to each pixel in each row, and the total value, total energy value of the row to be removed. Now, as you see, the first one is supposed to be 365, and I seem to be doing okay for this one, right? If I look at, let's see, let's run this one again. So I'm good with the 365, but the next one's supposed to be 539, and this is where I get 537. Why? That is the question, and it's not going to be easy to find because it's a pretty big picture. Well, it's not that big in reality, but in terms of, let me see. Okay, here. I actually have the test case here in my IDE in VS Code. Test, here we go. So as you can see, there is quite a bit of pixels. And one of the problems I'm going to have in debugging this is that the way my solution is written right now, I don't actually store, let me go back to what he sent us here. I don't actually store an array of all the indexes to be removed of the seam itself. I am using a recursive function and just storing the parent's index for each pixel. So, this pixel here will have the parent index in the seam, which would be 69 and 69, etc., etc. So I just start at the bottom, and then I look at the pixel. Okay, what's the next one that I'm supposed to be removing? I store that, and I just recursively go up the chain, basically, and removing the pixels. So in the end, I'm not left with a nice data structure like this, because really you don't need one, was my thinking, but for debugging purposes, it would be useful to have one. So I think a first thing we are going to do is implement some sort of way to store in a nice data structure the entire seam to be removed. That will make it easier to debug. Yep. So that's what we're gonna do. I think. But before that, there's one little bit of refactoring I want to do. I just want to move this pixel class out of this file here. Pixel class is just a data structure. It doesn't do anything. It just stores the pixels information with a bunch of accessors. So I wonder if there is, let's see. Move to new file. Look at that. Isn't that amazing? There we go. Even the name is nice. Kind of. I don't want a capital letter, uppercase letter. Like that. There we go. Perfect. Even did the import statement here. Beautiful. Okay, so that's taken care of. Now we're left with a file that's 107 lines long. Okay, so let's see. I gotta get back into this here. Where is find path of least energy? Okay. Remove path of least energy, compute cumulative energy. So the problem could be like, see, that's the thing. It could be that for some reason I'm computing. Hey, what's up, Free Steam? I could be computing the. There is one thing I noticed that is, I think, different from the other test cases that I've been passing, is that we are, let me just get it back up here. We are removing a seam right at the right edge of our screen, of our image. And I think it's the first time this is happening. So it could be a problem in the way I'm computing the energy of the pixels on the very edge, the right edge of the screen, the image. So that could be a problem. It could also be a problem in the way that I'm choosing which pixel to remove, which pixel to be part of the seam to remove, and that I have a feeling that might be it. Let's see, what am I doing here? I'm choosing, okay. So the way this works, right? I'm starting at the bottom of the screen, the image. I don't know why I see screen all the time, but at the bottom of the image, and I'm looking at well, basically it's kind of a recursive function. What you're doing is you're always looking at the pixels right above the one you're evaluating right now. So you're looking at the 3 pixels above, the one right above, the one to the northwest, and the one to the northeast, if you will, diagonally. And you have to choose which one has the least energy. The thing is, sometimes they're equal. You'll have 2 or 3 that are equal. And in that case, you're supposed to pick the leftmost one. It would be the northwest one, for instance, if that was part of the ones. I have a feeling I might not be doing that properly. Right now, I'm using let's see, it's right in here somewhere. If cumulative energy, current cumulative energy, sorted by top index. Yeah, so I'm just using JavaScript's array.sort function to find which one of the 3 parent pixels has the lowest energy. But I have a feeling that when the 2 of them are equal, it's not that array.sort function is not necessarily picking the right one. It's not picking the leftmost one. There might be so there might be a way to find out if that is a problem just by looking at the documentation. Let's see. So array.sort, that's the one. Methods, the default sort order is built upon converting the elements into strings, then comparing their sequences of UTF-16 code units values. The time and space complexity. Is not supplied, all non-undefined, blah, blah, blah. Sorted according to the return value of the compare function. Sorting array. Sorting with map. Interesting. I'm gonna have to look into that one day. It doesn't seem to say, but I would have thought that logically it would just keep the order. You know, if they're equal, they would just keep the order, but I don't know. I guess we'll have to debug and see if the problem is there. So those are the two places where I can really see the problem being. Either I'm computing the energy wrong, or I'm choosing the wrong pixel. Either way, we're going to have to debug to try to figure out which one it is, if it is one of those at all. Okay, so the first thing we need to do in order to be able to debug more easily is kind of create a way to store our seam to be removed. Where would I want to do that? Probably in the find path of least energy function. That seems to be the one that makes most sense. So what are we doing here? Return pixels. Okay, this is a reduce. Find top index of path. Yeah, I'm using that here. Okay. That's my current. I'm starting off with this here. That's my P. I should rename these at some point. Okay. Then I'm turning my current into a nice little object here. And I'm checking that the current is maybe equal to the previous one. Okay. In the pixels length -1. So we're checking for the, what are we doing? We're checking a row. Oh, right. Yeah, okay. Top index, find top index of path. I'm storing this. Yeah, okay. How am I getting to that though? Okay, I'm taking my pixels. Pixels.row. And column index. That's a recursive function here. Okay. Okay, I remember now what I'm doing here. I'm going back up the chain, right, until I hit the top. Boom. And then I get the top index of the path. Okay. But why am I doing that here, though? Okay, now I remember. Yeah, we're looking at each pixel at the bottom of our image. That's what we're doing, and we're comparing them to see which one has the least cumulative energy. And once we have that, well, we can just return the top index of that path, and then we can start removing. And I think this information was important, yeah, because if ever two paths have the same cumulative energy, you have to get the one that's on the left. The left one. Leftmost one. That's why I needed that. Okay. Now, so if the two pixels are the same, then what do we do? If they're the same, sorted by top index. Okay. Right. So that's cool. And then sorted by cumulative energy. So I don't think this is the problem here. Our problem is going to be most likely in the way we are computing the cumulative energy. I'm pretty sure. So let's see if seam is declared but never read. Oh, it looks like I had already had the idea here to store. So that's what we're going to do. Every time we select one. How are we going to do this though? Makes my code a little bit more complicated because right now I'm not bothering with. Oh no, I'm actually sorting. I'm actually storing that somewhere, right? Parent pixel, pixel, parent pixel, column index. So I am storing that. Let's see, how does he? Right. Pixel cumulative energy. So it's a simple matter of just pushing to our seam dot push seam dot push the actual pixel, right? Could probably do that. Yeah, and let's make that the whole pixel. For now, anyways, we'll get a bunch of information if we do that. Might help us debug a little bit. Sorry. All right, so if I do that, I end up with an array that stores my seam. Or not, actually. Because if that's pixels dot for each return row dot for each, and this is for, oh yeah, okay, for each row. So no, it should be a level higher. Oh, no, that doesn't work. Okay, how am I gonna do this? Right. That is not gonna work that way. I'm gonna have to do some extra work here. going to have to do some extra work just so that we can have access to the information we want. And we're going to do that right in our recursive function here. Yep. Yep. Let's do that. So we'll call this seam. It will be a pixel array. Initialize it to an empty array. And here's our pixel. If we start with, let's see here. We're starting at the bottom. Starting at the bottom of the seam. We're getting the pixels information. Row equals pixels length minus 1. That's right. Call index. I'm passing that in. That's correct. Send it with my pixel. If row equals 0, we know we're done. Otherwise, we call this recursively. So I guess basically all I need to do is right here, push the pixel. Seam dot push pixel. Now the thing is, do I want to return this? No, I mean it's just for debugging purposes. Let's do that for debugging purposes. Okay, so let's try that and see if it makes it a bit easier. Let's just go ahead and set a breakpoint here probably. Let's see. Okay. What do we get? In terms of, don't think I'm going to need the call stack. Pixels. That's our entire array, right? Which is 37 rows by 70 columns. I think that's correct if you look at our test. 70 by 37, right? Okay. So far so good. Where's the debug thing? Okay, there we go. Get back in here. Okay, and now, well, I really am just interested in, what if I do this here? Like that, and then I do that. Boom, okay. Seam. Yeah, that's not right. 2,590. That is probably because I am running this on each, yeah. Man. Okay, so it won't be this one here. just so this is a reduce. And once we're done with that, we end up with this kind of object here. Find path of least energy. It's here. So maybe I should just right. Where can I get that information? So this neat little thing here allows me to recursively go up. Okay, here's what I'm gonna do. Here's what I'm going to do. Right here, I'm gonna take my path of least energy dot top index. What's the x index? Top index. Top index is what we're interested in. So I'm just going to, let's call this, we're going to call this seam. Simple as that. Seam is going to be equal to some kind of, well, it's an array. We know we want to end up with a pixel array, right? So we need to initialize it to an empty array. And then what? And then map? No, not map. Although, maybe if I take pixels, yep, if I take pixels, I take the pixels array and I map, so for each row, okay, we're getting somewhere. So we've got the row, and we've got, we're not really interested in the index. All I'm going to need is the row, I think. Put that for now. Let's see here. If I do row, path of least energy dot top index. We get our starting pixel. Yeah, that wouldn't work. Cumulative energy. Find my myself coming back here. Unless I have to store an array of all seams. I mean, I could completely change the way I'm doing this, but I think it would be more computationally heavy to do it the way I'm thinking now. Would make it easier to debug though, but I could do it both ways. Keep the way I'm doing it, then on top of that, keep the... Yeah, why don't we try that? Why don't we try that? So we'll actually keep an array. Yeah. We could do that. So, okay. Then I need to add to my pixel class. I need to add... Do I push to GitHub during the stream? I usually don't, unless I don't know. Sometimes I do, but I usually don't. I usually just push at the end. But I really should do it more often, I guess. Would you see a benefit to that, FreeSteam, if I were to push more often during the stream? That wasn't working in here. Okay. So I could add... I've got cumulative energy here, so I'll add seam, which will be just an array of... Should I just put the entire pixel in there? I might do that. I'm just thinking how you can keep audience involved. Right, so are you thinking like people could actually work on the repo as I'm working on it? Like maybe add a timer message with link to problem you are doing. I have that already. It'll show up. I don't have it like every 2 minutes because it would get annoying, but I think I got it running every few minutes. Should see it in chat right now. Extreme elements. I'm currently working on solving the seam carving puzzle. Blah blah blah. At least help debug. Yeah, that's a good point. That's a good point. All right. Yeah, that's not a bad idea. I mean, want to take a crack at it? The only little change I did was move a class out of a file. I didn't change anything to the functionality of the solution. You don't see it. Okay, and you've been in here since the beginning? That's weird, because I got a bunch of messages on the timer that you should be seeing every few minutes, I guess. I'll let you know next time one pops up, and we'll see if you see it. Okay, so pixel, let's initialize that to an empty array. And just for good measure, we'll add some getters and setters. I don't like that. Oops. I cannot rename this element. Why? Why can't I? I switched machines from laptop to computer. Okay, okay, so maybe the message popped up while you were switching machines or whatever. Gonna have that in here. Seam, I've got it right here. All right. Right. Here. Okay. Link to your GitHub repo also, please. That would be a good idea, yeah. Yeah. Yep. Let me get that. We're working on seam carving. There we go. Well, actually, the repo is like, I've got all my code and game stuff in there. But okay, so here. That's the repo. So what was I doing? Oh yeah, I was thinking of for each pixel that is selected, which is pixel, that parent pixel column index equals sorted. So that's the one. Yep. So now what we need to do is pixel dot seam dot push, and we are going to shove. We're going to shove this here. Nope. Just that. Nope. Why not? What are we? Oh, I'm already... Okay, so then I need... What do I have in here? I've got my X index, cumulative energy, started array 0, X index. So that would be the index. All I need to do is look at, what am I looking at here? I've got my row here, so pixels. Sorter index, that's the row, should be here. And the column index. Oh no, Y. There we go. So, okay, do you see that message that just popped up? There should be a message that says, every minute you spend in this channel earns you frog legs, blah, blah, blah. Do you see that? Okay. So yeah, so it works. It should, the message with the link to the coding game puzzle should pop up at some point. I didn't set them for like, I don't know what the timer is. It's probably like 10 minutes or something. Okay, so now this should push the pixel we're interested in to our current pixel. If I do that, I actually need to, no, 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 no. I actually need to push myself to, huh. So each pixel will start actually with themselves in here. Yeah. Okay. Oh, there you go. See? A bunch of them that popped up. I'm currently working on solving the seam carving puzzle on codinggame.com. Here's the link. Boom. Okay, so we're starting off at the top row. In our seam array, we've got our own pixel. Now, as I'm computing cumulative energy, for each one, if y equals 0, we're at the top row. We don't need to change anything here. But if we're not, we're getting northwest, northeast, and north. And we are computing the cumulative energy. How? If x is not equal to 0. Oh, okay. So we're computing cumulative energy for each if we were to take, okay, right. Then we choose between which parent gives us the least amount of energy. And that's what we record as our cumulative energy by adding our own. Calculus, that costs more. Costs more than what? But yeah, it is calculus. Gotta get the gradients and the gradient magnitude. It's not too complicated, but just enough to be fun. Oh, if math is involved, you double the rate. Yeah, if only I was getting paid for this. 0 times 2 is still 0. Hey, drops the bait. How are ya? Okay, so I essentially doing good, thanks. I have to debug this little problem I have in my solution here. And I'm modifying my code to have a better view of what's going on. All right, so let's see. We're taking the I basically need to take the previous pixel, right, and add my own. That's basically what I'm doing right here. So pixel y, sorted array of x pixel, so that's the parent. And I'm interested in x index. I'm passing in the parent. I would need to take the parent's seam and unpack it like that using the very practical spread operator that was introduced in JavaScript a while ago. So now I've got that, then I can add myself. Actually, would that be the right way to do this? I already have this in there. So I'm starting with the top, then I go at the bottom. If I go add me, then add the other one. Yeah, I think that works. We are about to find out. We are about to find out. How are we going to find out? We're going to put a breakpoint. I'm going to point the breakpoint. Let's see. Let's put a breakpoint here. Yep. F5. Okay. Let's see, what do I have in here? I got my pixels array. Now, if I look at any pixel just for kicks. Seam 2. Right. Okay. If I take light pixels, so it says 37 deep. So let's say I would to take the very last one. Anyone will do. I look at the seam. Oh. Yep, that's not right. That's not what we want. What's going on here? Only have okay. Why? Pixel seam push. I'm taking the pixel from, oh, yeah, of course. It's got to be the parent pixel. So that would work, I believe. But I've been wrong before. Okay. So how do you run this thing? Okay. Well, if you just want to run the, well, let me just show you. It'll be easier. It'll be easier. So the repo is the entire, I've got solutions to all of the different code and game things I've been working on, puzzles I've been working on. Right now I've got it set up so that if you just hit F5, it'll run the test suite. And it's only got the test suite for the current puzzle I'm working on, seam carving, turned on basically. So hitting F5 will, from the root, yeah, from the root. You don't need to worry about where you're calling it from, because it's pulling from this launch.json config thing. Like, I don't know if you've opened it in VS Code or in just Visual Studio. Like what? But need to npm install from the. Oh yeah, you do. Yep. Actually, you need to npm install from the root, and yeah, you need to install from the root, and I think also from the seam carving directory, because the test suite stuff I've got on the root level, but the project, like the puzzle related stuff, I've got a few dependencies that are just in here, I think. I've got all that stuff automated, so I don't really think about it anymore. But so yeah, I would start by npm install from the root, then going into seam carving, and npm install there as well. And then you should be good to just hit F5 and it should work. Or Control F5 if you don't have any breakpoints and you don't want to debug, it'll just run the test suite if you do Control F5. Test suite, 1 failed, 1 skipped, 18 skipped, 19 total snapshots, ran all test suites, waiting for a debugger to disconnect. Yeah, okay. So let's see what I get when I run it. Yep, getting the same thing. But that might be because I was maximum call stack size exceeded. Now, let me just comment that out. You don't have that in your stuff anyways. Where was I working on? This stuff here. Forget about that for now. Okay. 846. So that's the one I'm failing. Yeah. So that's good. That's what we want, because if you look at PGM image test, I've got for the last test case here, height 37 and width -15. I've added dot only to my test, so that way it only runs this one. I know the other ones pass right now, so I just wanted to have this one running. But if you were to remove the dot only, it would run all the test cases in that suite. So you're set up properly, and it is failing. It's supposed to be failing. That's the test case that I'm having a hard time debugging for. Okay, so it apparently didn't enjoy. I have not even read the problem yet. It's not that complicated. Like, the algorithm is not like super complicated, but you know, there's a few different steps you need to go through, and there's a few like edge, really edge cases, because you have to deal differently with the edges of your image. Hey, Dungeoneer, Thanks for the follow. So, well, maybe I can just give you a quick overview of what we're doing here. Is we have this image uh, PGM file, which is, let me just get back to my test. Okay, so this is what it looks like. I'll just take a smaller test case so it fits in the screen better. Okay. So it's basically a string. The first few lines are just like metadata stuff, and then these represent pixels, line by line, row by row, columns. And the value you see here, the number, is the grayscale value from 0 to 255, right? And the idea is that the algorithm for seam carving, what it basically does is it looks at your image, and let's say you wanted to reduce the size of your image horizontally, right? So the width, you wanted to reduce the width of your image. There's different ways to do that. You could crop manually. You could just basically squeeze it, which would look horrible. Or you can do some, I think they call it image retargeting. Basically, is the algorithm looks at the image, tries to figure out the least important part of the image and get rid of that. And so seam carving is one of those kind of algorithms. And what it does is it compares each pixel. It looks at each pixel, and it looks at the surrounding pixels, and it tries to figure out which pixels change the least. So, for instance, a pixel in the middle of a blue sky would be a good candidate for removal because you wouldn't change much to the image by removing that pixel. But it doesn't remove one pixel at a time. It looks for a seam, for an entire path through the image. So if you're, because we want to change the size horizontally in this case. So we need to remove one pixel per row. Which one should you remove though? That's the purpose of this algorithm. It looks for a path through the image, and it tries to figure out which one will least impact the image by its removal. It's not that complicated. It's just you need to go through, you need to parse the whole thing first. Then you need to look at each pixel and give it some sort of a score, a value based on the surrounding pixels. And then you need to choose basically which path through the image is the one that will impact the image the less by its removal. And I'm off on this in this test case, my last test case. I'm off by just a little bit on the second seam. The first seam I seem to have the right one, at least the seam value. Oh yeah, important point for this puzzle. What they're actually wanting us to do, we're not returning the new image after removing the seams or even removing one seam. All they want is for us to return the score value of the seam that was removed. So, for instance, right now, for this test case, I'm supposed to be returning 365, 539, 661, etc., etc. And when I run the test case, I do return 365 for the first seam. Great. But that doesn't necessarily mean that I'm removing the proper pixels. It could just mean that I'm removing a seam that has that value, but it's not the actual one that they want us to remove. And that subsequently screws up the next one, because here I'm getting 537 instead of 539. So that's what I have to try to figure out. And it's not easy because of the way I've written the code. I've written it with recursion in mind. I'm not keeping track of, in a neat little way, I'm not keeping track of all the indexes of the seam that I remove. I just do it and tally up the value. as I'm removing it, yeah, basically. So anyways. So now I'm thinking that I should have a data structure that just keeps track of the index for each pixel in each seam, at least so that I can debug more easily. So you know what, let's make this, just an index of number for now. So from the start point in the first row, the second row can only be one of the three. The one below, onto the left or onto the right. That is correct. Well, actually, no, it's the other. Well, yeah, that's correct. But the way to look at it is that you actually start off, when you're trying to determine a path, you start off with the second row, and for each pixel, you look at the ones on top, basically your parent pixels, and the one to the, you're correct, it's got a touch, at least diagonally, so northwest, north, or northeast. So the way this works, the first step, oh, and if, hold on a sec, let me just, this will help a little bit visually, more than just my explanations. This one helps too if you're interested, although this isn't exactly how it's implemented for this puzzle. This one is for you know, full color images, so it doesn't use the same kind of way to score each pixel. But here, let me see if I can, okay, this gives a good overview of how this works. So this is the score value of each pixel right here, the one in the middle. That's the score value for the first row, and we obtain that by looking at each row, each pixel above, below, to the left, to the right, and then we score it depending on how much this changes, the gradients, right? And now, once we've got that, we go below, and now we look. Okay, we've got, oh, so I'm sorry, this here, the upper right, upper left corner is the actual value, the score, the energy, whatever you want to call it, for each pixel. So when you go below here, what you do is you look, so you've got your score for this pixel, but you look at the parents, the row above, and you figure out which one has the least amount of energy, least amount of cumulative energy. It would be 1, because that's, you know, our choices here is, well, we got nothing here, we got 1, and we got 4. So it would be this one. So then the cumulative energy for this pixel becomes 4. Do the same thing here. The energy for this pixel is 2. You look at those 3. This is the one with the least energy. Then this becomes 3, so on and so forth. Go down to the next row. Start here. Well, this one has an energy of 5. Look at the top row. We've got these two choices here. The least cumulative energy is 3, so 5 plus 3, we end up with 8. And you go down the entire image doing that. Once you're done with that, you look at the bottom row, and you should have, you know, a cumulative energy for each pixel in the bottom row. You choose the one that has the least cumulative energy, and that's the end of your seam. So you can just go back up, and you'll know which pixels you need to remove. That's essentially the way I'm doing it now. See, I'm not storing as I go. I'm not storing the index of each pixel in the seam. I'm just storing cumulative energy. But now the problem is I'm trying to debug, and for some reason I don't have the right seams, I don't have the right path, but I don't have a nice, neat little data structure that says, okay, well, for this pixel here, you've, you know, here's the indexes of all the previous pixels in the path. I don't. I just have the cumulative energy. So how do you score? Okay, how do you score the seam? The number printed is the total of seam. That's correct. The number printed is the total for the seam that is to be removed. How do you score the seam? I kind of just explained it. I don't know if that wasn't clear enough. Probably not. But yeah, that's how you score the seam. Once you get to the bottom row, okay, you get it. Good. So yeah, once you get to the bottom row, the cumulative energy for the pixel is actually the value of the entire seam, the energy value for the entire seam. So now what I'm trying to do, because I don't know if you saw this at the beginning of the stream, but I asked the creator of the puzzle, I told him I was having a problem with this test case, and he was kind enough to provide me with this information here, which gives me the total value, score value of each seam that's to be removed, the index of each pixel, right, in order, starting at the top. So for the first row, pixel index 69 is the one to be removed, and that's its value. It's not the cumulative value, but it's the value of each pixel that's to be removed. The thing is, I don't have any way in my the way I written my code, I don't have that kind of data structure, right? I'm just kind of doing it recursively. I'm just going through the thing and doing what I have to do. So that's why I'm trying to modify my code so I can have an easy way to debug this. Otherwise, I have to go in the debugger and kind of, run through the code step by step and keep track for each, as the algorithm's going down the image, try to keep track of, which index it's which pixel it's using. Okay, so if there are two, how do you choose? Very good question. Can't print that info. Yeah, I guess I could, but it would get crazy. I mean, look at the, no, it would be, I don't think it would work. You couldn't make any sense of it because the algorithm's not going down seam by seam. It's going row by row and storing, the cumulative value for each pixel. Hey, Ryan Roberts, Cubs lover. Sup, man? Have you tried LeetCode? I have not. I don't know what it is. Is that another puzzle kind of website or? Yeah, you freeze team. You do have to remove the seam because let me just make that very clear for you. So, of course, at first with the easy test cases, they only want you to remove one seam. So whether or not you actually remove it from your image data structure doesn't make a difference, right? But once you start having, let's see, once they start asking you, there you go. Once they start asking you to remove more than one seam, this is the output they're expecting, right? So they want the value for the one seam, to the second seam, third seam. If you don't actually remove the pixels from your image data structure, well, your calculation for the second seam will be off, right? So you do have to remove the seam, but they're not interested in receiving the image or receiving the seam. They just want to know the cumulative energy value of the seam you've removed. Okay, Ryan, what are you saying here? But I did lots of research. Missed a few here, sorry. Anyway, I took my first CS course program. Hey, thanks for the follow, Ryan. Let me just read what you wrote there. I took my first CS course program, Design 1, got an A in the basic building block concepts. Made sense for me. Classes and object made sense for me, but I did lots of research. LeetCode gives you stuff from interviews and helps you apply the right data structure. I just get nervous about failing college course. Never happened to me, but it can happen. People tell me I got this degree in a bag. But I'm playing it safe, like prepping for my courses for... Okay, cool. Well, good luck with that. I'm sure you'll do well. Okay, and freeze team. What are you saying? You don't actually remove the seam. I haven't like lead code. Okay, so you've tried it. Cool. So where do you remove it? Okay. So to answer your question, freeze team, you remove it. Well, I remove it anyways. In there you go. In this function here, remove path of least energy. And if you look at my like my main function, which is remove seams, that is the last thing I do. It's the last thing I do. So if we build array there, can we get the data he has? In remove path of least energy. You know what? We may be able to do it there. We may be able to do it there. How are we doing it here? We are starting at the top row. Yep, you're right. This is actually the best place to do it. It's the simplest one. I've been racking my brains trying to shove it in the compute cumulative energies function, but yeah, this would be the easiest one, I think. Actually, you know what? We could probably print it from there. I mean, at least for starters. Why don't we do that? Yeah, let's do that. Just yeah, just so we can compare. Good call, man. Good call. Okay. So let's see. Yeah, fails on the second one. Well, it fails on the second one, but I have a feeling that that a first seam is the problem. But we'll see. I think my feeling is that the first seam is my problem, but that like through some fluke, the value of the seam that I'm removing first is actually the value that we're expecting, but it's like there's one pixel somewhere that I'm not removing the right one. Okay, so let's do that. Current index to remove. Path of least energy dot x. Let next into. How am I doing this? Yeah, okay. So of course it's going to be in the for loop. This is what I'm splicing here. So splicing 1 pixels.y. Okay. So if I do console.log and y is the row, so that would be useful to have. Just y is the row, and then we'll get the x. We'll call it x. Current index to remove. That should give us what we want, I think. Might still not be easy to read though on the screen, but we'll see. So let's try that. Just bring that up, way up. Oh. Did it still go through with it? It doesn't look like it did. Still got my seams that push thing giving us a hard time. Just give me a sec here. Get seam number array, return this dot seam. Y get and set accessors must have the same type. Oh, okay. Easy fix. The end might not even have to use this, but Now, did I have another error in here? Nope, I don't think so. Let's just run it again. Okay. We've got what we're looking for here. Not super easy to... Oh, right, it's doing it for the entire thing, right? Not just the first seam. Okay, so, but still, if we start at the beginning, we should have what we want, I think. Oh no. It cut off the, I can't scroll all the way back. Put break at the end of the for loop. Yeah. Yeah. Let's see. Right here. It'll screw up the rest of the algorithm, but we don't really care for now, right? Okay. Let's do that. F5. Oh. Right, that would have been better. But this should still work though, right? Let's see. Did it? It's a sweet type error. Can I read? Oh yeah, it screws up everything. Oh man. Okay. How about here? Let's do that. I'll remove my other breakpoint though. There we go. So let's see. Oh, I don't think it... Oh, I need to probably put the breakpoint right below. I stopped in the loop, that's right, yeah, okay. Gotta put it here, right? This should work. Yeah, let's give it a try. Huh. Where am I going wrong here? Isn't there like an inline breakpoint thing? How do I... Oh. How about this? Would that work? I don't know. Don't know what I'm doing. Okay. No. Add a debugger. Oh, I don't know what that means. I don't know what that means. So teach me. Add inline breakpoint. That's what I was looking for before. I don't know if that'll make a difference. Doesn't. Okay. But yeah, see if the inline thing works. Yeah, I was trying to do it here. Oh. Oh no, it just keeps pushing it. I don't think it makes a difference though. But let's see. see now. No, doesn't. It does not. Which is kind of odd, right? I mean, we are after the for loop, so what if I was to break right here? I should still see at least one console log, right? That's probably on parse of the function. Yeah. Yeah. It stops right there, but so it's got everything it needs there. It's got all the info, but for some reason after loop or just a debugger. Yeah, I don't know what that what do you mean by that? Oh, a bogus statement after look. That probably on par. Add a bogus statement after look. Loop. Ah, okay. Oh, because you think it's something with parsing that I bet just doesn't flush console. Okay. So something like const debugging equals as freaking hard. Oh, that. Let's try this. Let's try that here. Whoops. I'll get out of here. Okay. Hold on. Yeah. F5. Still no. What? What? How about I just do this? Nope. How about one more? Nope. Could it be that when I run the debugger, could it be logging to somewhere else, like some other process that I'm not actually seeing on screen? That would be odd, right? That normally it wouldn't do that. Okay. Let's test my theory and just put a yo. Very helpful message. And let's see what happens. Yeah, see? No. So I think yeah, I bet just doesn't flush console. Yeah, I think I understand what you mean by that. So we'll basically see it once we're done with the debugging. It'll flush all the console logs. If I just do continue, for instance. No, let's just, how do I keep going without, just don't break anymore. Okay, here, there we go. Yeah, so that's, yeah. It might be jest, I don't know how this works, but this doesn't work. Okay, so let's do this then. which will be similar to what we're trying to do. I'll get rid of this thing here. Okay. So instead of logging, we'll just make a temporary array here. Let seam equals an array, and then we'll just push everything there. So seam.push, and then we'll just use the debugger and look at it from there. Essentially the same thing. Just verbose. And that would give us what? It would log the stuff as it's... I'll look into it. But this should work here. Per some site I just Googled. Cool. I don't know if I would want that turned on usually though. It could get annoying. Oh, I'll give it a try, but let's try this first. Okay, there we go. What do we have in here? There we go. Okay. Okay. Don't need this, so let's make some room. Almost fit. Now I need to compare with our little friend here. Has put that all on screen here for you guys. Okay. Let's do this. So, oh, this would be, we'd have to start here. Okay. So 69, 69, 69, 69, 60. Okay, I'm already lost 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, good. And 68. Yep. Then, oh, there we go. We've this is wrong. This is wrong right here. Right? Row 7 should be 67. 0, 1, 2, 3, 4, 5, 6, 7. Yep. Row 7 should be 67, but it's not. Let me write that down because row 7 is our problem. So, okay. Now let's go take a look at why it's a problem. And for that, we're going to need to look at our compute cumulative energy function first. Maybe. Could add a conditional breakpoint. Oh yeah, I could have done that. Oh no. Oh, you mean for yeah, you can do. I've used them, conditional breakpoints. So that's what we're going to do. We're going to go to find path of least energy, and we're going to add our breakpoint right here. And we're going to make it, what are we looking for? We're looking for index 7, so row 7. Return pixels up, length -1. Oh, this might not be. Yeah, it is the 7th one. Not the 7th one, it's the index 7, I think. Oh, now I don't know anymore. Hold on. 0, 1, 2, 3, 4, 5, 6, 7. Right, because the rest was fine. here. 6, 7. Yeah, we've got two 68s back to back, and we're not supposed to. We're supposed to get 68 and then 67. So it is index 7. Yeah, y equals 7. Wait, in here? Will that work? I don't think I have a y. Oh, unless you mean in the, if we keep doing it in here. Yeah, we could. You're right. We might as well keep going here. So y equals 7. Let's do that. Wow, that's what's do I still have the value when removing? That's what I was just trying to figure out. We do have the pixels array though, so that's the entire thing. What do I have in here? I don't think I have the pixel itself. I'm just pixels.y.splice current index. We can just take a look like this. It's not the end of the world, I guess. So 7, and then I have to look at columns. 60. Oh, crap. Yeah, because I'm removing them as I go, right? So yeah, this is probably not the best place to do that. We should probably do it in when I'm actually computing the cumulative value, energy value. That's probably the right place to do this. So how about I just put a, oops. If I put a break here, make it conditional on y being 7. That should work. Let's just start over. Okay. And this is actually, what is the pixel? If we're looking at the pixel here, pixel is actually x0. Oh, okay. So let's make this our conditional here. Edit breakpoint. So y is equal 7 and x. Oh, how did I even work? I didn't have the proper what? Anyways, x is equal to what were we expecting here? 67 or 68 we're supposed to get 68, right? So, but we're returning, no, we're supposed to get 67, but we're returning 68. So let's stop at 67 and see what's going on there. Okay. X is 67. That's what we want. So this should be the right pixel. Parent pixel column index is 68. That's correct. Now, okay. Let's get our thing back here. So we're supposed to be, yeah, that's not going to help us though. Because right now I'm looking at 67. '67 should be So 0, 1, 2, 3, that's a 6. Where's my y here, just to make sure I'm not... Y is 7, okay, good. 0, 1, 2, 3, 4, 5, 6, 7. So the value should be 2, and it is. It is. But here's the thing, though. 67, parents should be 68, and that's what I'm getting here. So where's the problem? Why am I choosing? Oh, okay. The problem might actually be happening further down the image. Where would it? Because this seems right, right? 67 has been... Well, okay, hold on. There's another thing I can do. I've got my cumulative energy here, which is 86, and I should be at 0 plus 23 plus 10 plus 23 plus 7 plus 15 plus 6 plus 2. 86, right. So presumably, this pixel is being scored properly. But for some reason, the path that's being removed, we're using the next pixel over, 68. So let's go to that. Would I, if I just do this? Yeah, now we're at 68. Let's just keep going in there. All this fills up. Sorting, blah, blah, blah. Just want to get to the end here. Push. Okay. So 68. Let's look at our pixel here. Aha. C. Okay. Yeah, you're right. It would have been faster. I always get confused with step over, and sometimes I use step over and I end up like, I'm at a level that's too high, so I step over the entire thing. And okay. So I think we've identified our problem here. Hey, thanks for following. Ibn Hamdan. Anyways, you. Thanks for following. Okay. So do you see what's going on here? We're looking at our pixel 68, index 68 on row 7, which is what we're getting here, right? We should, we are showing 68 instead of 67. And here's the problem. It's got the same cumulative value. It's not supposed to increase. We're on the same row here. So we looked at pixel 67. Now I wanted to look at pixel 68 because 68 is the one that we're displaying, but we should be displaying 67. And we're trying to figure out why we're choosing 68 instead of 67. And now, that's right, we're just choosing the wrong one. And here's why. Well, I mean, that's part of the, we're getting there. They have the same cumulative energy. So at that point in the image, at that level, as we're going down the rows, both of them have 86. And for some reason, it's choosing 68 over on the right instead of 67 on the left, which is the one that it should choose. When there's equality, it should choose the leftmost one. I had an inkling that that was going to be the problem. But, okay, so now, here's the thing. we're just going to redo this here. And actually, okay, here. We'll do your... So if I do step over from here, it'll just... What will it do? Okay. And if I do step over again, will it... Let's try it. Okay, okay. It just won't go in the... Okay. All right. Good, 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 good. And this. Now. Okay, here's the deal. Oh no, I should have stopped at... I should have stopped at this here. Yeah, this is what we're looking for. We should look at what our sorting array is doing, because that's the problem here. It's putting our index 68 first. And there really isn't any reason for it to do that. So okay, so let's restart here. And it's the breakpoint, and we step over. Now we're into 68, and I'm looking for this. Oh, okay, this one I want to step into. Right. There we go. So we're looking at... Okay, so right now we're evaluating index 67 and 68. So we're looking at our, it's looking at our, basically our northwest and northeast. And, oh crap. I just figured it out, I think. No, that shouldn't. Yep, yep. I think I just figured it out. Let's give this a try. See this here? I've got northwest, northeast, north. I think the sorting function, when two of them are equal, will just return them in the order they were. They are in the original array. And I've screwed this up. It should be northeast, north, northwest, north, northeast. How much you want to bet this is going to fix it? Okay, let's run it without the debugger. Come on. Yes! 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 All right. Well, that was fun. Oh, man. Imagine that. That's what it took. That's what it took to get to that problem. About an hour and 40 minutes. Crazy. Okay, so I don't need you anymore, and I'm actually thinking now that some evil liquid. Snowfrog froze some evil liquid, yeah, well. I don't know, there might be a bit of liquid left in this piece of code. Now I'm just gonna get rid of this, because it really... not necessary in this algorithm. Oh, wait. Did I just pixel that seam that push? Yep. Although, what do you think? Do you think this adds a lot of overhead, a lot of computationally it shouldn't be that bad, but it takes up a lot of memory, I'm guessing, right? If you have like a huge image. Yeah, so I'll just remove it. I will leave it in my pixel class though. Oh no, I shouldn't. I should probably remove it there too. It'll just be... Okay, let's make sure we didn't break anything. Alright, we're still good. Now what we're going to do is run all of our previous tests. Make sure we didn't break anything there too. So we'll just remove our only right there. There we go. Okay, so now what we can try to do is actually run it in our Code and Game engine. 1 hour and 20 minutes lines of code, change to fix equal 1. I'm not sure I get it there, what you're trying to say. Changed 1 hour and 20 minutes, or 1 minute and 20 seconds, or lines of code change. 1 line of code change to fix the problem. Yeah. Yeah, that's right. Okay, so let's play all the test cases. I have a feeling it's going to work now. Till the end. Come on. There we go. And we're done. We are done, people. Happens all the time, man. Yeah, I have a feeling it does. I have a feeling it does. So, wow, great. Awesome stuff. Thanks for your help. Very helpful. So how about I push that to GitHub. Fixed bug with sorting order in, what was it called, this thing? It wasn't here, wasn't it? Yep. In compute cumulative energy function. There we go. Push that to GitHub. How about we see if we can refactor some stuff in here. Got a few minutes left. I'm going to stream Wednesdays from 1 to 3 Thailand time, UTC +7. So that would be, if I'm not mistaken, you're like 11 hours not behind, ahead of us. Like, what time is it over there right now? It's 10:48 a.m. here. So it's probably 9:48 in the evening over there, right? If I remember. Yeah, 9:48 p.m. So your 1 p.m. would be my 2 a.m. Yep, I don't think I'll be staying up for that. Would like to, though. You stream me on your channel, right? Oh, that's a good, I don't think let me check right now so I don't forget. I don't know that I've added you because you weren't streaming yet. And you weren't sure if you were going to do it from your personal or the Freeze Team account. So
put in something smaller?
Not the channel. No. Okay. Let's see here. Oh yeah, I did add. I did. I managed not to swear the whole stream. That's good. That's good. So yeah, I've got you as I'm hosting you on my channel. I'm hosting you on my channel. Plus, are you gonna be saving it to YouTube? Because then I can watch it later. Oh, I can also watch it on Twitch, right? It saves it for a few days. So that's good. Let me see if there's any obvious refactoring I can do here before my time runs out. The first one went pretty well. Yeah, that's what you were saying, eh? You got some good feedback too from the folks at what's it called again? That crypto, wasn't it a crypto wallet thing, or can't remember. 10 grams, that's right, yeah. So I don't know if you noticed, looking at my screen there, if you noticed, I've got these complexity things here for each function. That's a neat little extension for VS Code. If ever you're interested in that. So this would be the most complicated. What extension is that? Yeah, let me show you. It is called, what's it called? Did I skip it there? Code Metrics. Code Metrics. Works really well. So if we could simplify this, this would be nice. Essentially, find path of least energy is just a wrapper over a reduce. Added. Thanks. No problem, man. Got a bunch of nice little extensions I'm using in VS Code. I know you use Visual Studio more than you do VS Code, but you probably have some front-end stuff once in a while where you have to fool around in TypeScript and JavaScript, and maybe you use VS Code for that. So, yeah. So find path of least energy is just a wrapper over this reduce function right here, and within that reduce function, yeah. Okay, so you do your VS Code and your TypeScript in VS Code. Cool. Then you might be interested, let's see, in, I love this one here, bracket pair colorizer. I don't know if you know about this one, but I find it very useful. Oops. And let's see what else. Oh, this is nice. It's a small thing, but it's, I don't know if you often end up having many different windows of VS Code open. This will actually colorize the windows differently, so it'll be easier to track, you know, which project is in which window. TSLint, of course, Visual Studio IntelliCode, the equivalent of the same in Visual Studio for C# and C++, I think. You got it. Okay. And then, oh, this is really cool. Although they have a free version, but I'm actually paying for the premium one. It's about $50 a year, I think. Basically, oh yeah, Beautify, I don't think I'm using it. It shows it as a recommended, but I'm not using it right now. Not in this project anyways. Let me show you Quokka, because that's really cool stuff. And it works both in TypeScript and in JavaScript. So let's take our main no, that's going to be trouble. Let's take this here. Quokka will basically evaluate live your file. So let me just get rid of this here. Let's say I was to do let x equals 10 plus 12, something like that, right? I could then just do this. I'd have to start Quokka though on the file, start on current file. Boom. See? It lives evaluate your stuff. And I could, if I just do this like that here, it'll show me as well. And now, if I do, let's see, what is that it? No, that's just the same thing, because it'll actually do it to Okay, let's see. Let's say let y equals 23, and then let z equals x plus y. So x plus y. So if I do that here, you'll get the, oh, did I just screw something up here? Fail to instrument steam. Oh, okay, good. 45, right. But let's say I wanted to know what's x again. I don't remember what x is. Then you could just go here, right next to it, and do this. Like that. Boom. And then x is 22. So it's pretty cool, and it even has, no, I can't remember how to do it, but it'll actually give you like performance data. How does this work? I can't, maybe like that? No. Hold on. Quokka.js. Docs right here. Live logging works with the, oh yeah, and it has live coverage too. Do you see this here? So you can just at a quick glance see which lines of code aren't are either throwing an error or something like that, or are covered or not, or if they're not, or if they're half covered. For instance, this if statement there, it had a yellow. That's because it wasn't, I think all the branches weren't evaluated or something like that. Oh, I think this might identify expression, live comments. Will expand your object. Yeah, okay. I'm looking for the performance one. Where is it? Nope. Okay, live performance. There we go. Oh, I was missing a dot. So, if I did this like that, I think. No, missing a. There we go. So you get the performance, and I think you can actually get more than that. Oh, that's for loops. Yeah, see how it gives you here? I don't know if you're still with me on this. But actually, I don't even know what these Greek letters mean, but they have to do with like how long it takes for the entire loop, how long per loop, and then like the longest one and the shortest one, or something like that. It can be really useful. Yeah, yeah, this is the sum, yeah. But these here, I think this is like the average. Yeah, okay. So the sum, the average for each go around for each loop, and then the longest one. Oh no, the shortest one and the longest one, something like that. Anyways, it's pretty useful. I like it. I like it to try stuff out. You know, it's a lot of fun to get some live feedback right away, without having to run the actual file and the whole thing. And summation. Okay, cool. I'll just stop that. Okay. Well, that's it for me. It is 11 o'clock. I'm gonna end the stream there. First, thanks for sticking around. Free Steam, it was fun. Thanks for helping out with the debugging and the few tips. That was very helpful. Uppercase is used as a symbol for the summation operator. Yeah. Yep. That one I knew. It's the other ones I don't know. All right, man. See you around. Take care.